So we're really excited to get to talk about this stuff. We've given some talks on GraphQL before, and we'll be, for those of you who don't know it, that's all right. We'll do a little bit of a refresher, but there's some particularly exciting stuff that we're going to get to talk about today. Stuff that came out of what we're trying to do at CargoSense. And we've been incredibly fortunate to have the support of our company for building Absinthe and for dog fooding all of the features that we build for it.
We've got an incredibly small development team, and I'm the CTO, so I just decided, hey, Elixir sounds good, let's do that. Which is a real bonus, us being able to just kind of make those decisions. And GraphQL was just the perfect fit for us. We'll get into why. Okay, well, what is GraphQL? It's pretty simple. People don't seem to figure this part out, that it's a graph query language. And that's basically all it is. People think of GraphQL as an API. It's actually a lot more basic than that. It's actually probably closer to SQL. It's just that we tend to push it across the wire as an API. A little bit of history here. Facebook developed GraphQL internally about 2012, and it was open source in 2015. And people started getting really excited about something called Relay, which is a JavaScript client-side framework. There's now a modern version of it. There's a classic version. And like most things that come out of a company, the classic version was complicated, kind of hard to work with. The modern version, however, is much more flexible. There's other frameworks that use it as well now, things like Apollo Client and the Apollo framework. And you can use it from Elm and a bunch of other places as well. But primarily, most of the things out there are using it with React. There's a lot of other server-side implementations as well because there's a specification. Right.
The premise of GraphQL is that your data is a graph and that there's going to be some kind of schema with which you build that graph. And then the query language bit is a way of getting stuff out of that graph. So this is, in a whole lot of ways, easier to show than it is to talk about. So let's move all of this over here. So this is a little example application that we built as part of the tutorial, and then we've added a couple little things to it for the talk. This tool is called GraphQL. It ships with Absinthe. It's an open source thing. We didn't build it. It's just a little piece of JavaScript that can talk to our schema, figure out what's possible in that schema, and then let us write little queries here on the left, and we'll get responses. So we'll go into this app a little bit more. But the idea with GraphQL is you can write a query, and we're going to ask for some orders. And then for each of the order, we can do something very simple, like asking for the customer number on that order. And if we run this, you're going to get exactly what you asked for. You got your data, orders, and the customer number. You can ask for a little more. Maybe we care about showing the state of the order for each of these customers. And hey, all these states are completed. You can get more data. So it's not just simply
one layer deep.
One layer deep. So every order, you've got the actual items that were ordered, and you might care about the quantity and the price, and you need the actual menu thing that you asked for, and we'll get with the name. And so you can ask for all this stuff too. And under the covers, each of these little identifiers you're seeing corresponds to something in the schema. So I can't just type random stuff and hope it will work. Actually, this will give you some really nice errors because it knows what's possible. So this is the idea. Let's dig a little bit into.
Ben, can you open up Docs too while you're in
there? So this Docs here is built in. This is a little bit compressed. I apologize. We can make this a little bit bigger. I tried. So on our root query, we looked at the orders, and we can visit the orders on here. You'll notice there's actually a filter we're not using. And so, OK, cool, that returns an order type. Here's the things that are possible on an order. We went through no effort at all to build this. This will show you how the tool that you use to build these schemas in Elixir. When you build that schema provides this capability to actually execute stuff. And at the same time, for free, you get docs out of it, which is pretty nice. So the tool that you would use to build this is Absinthe. And this is what Bruce and I have co-written over the last couple of years.
Yeah, so the reason this started, we can blame it on Chris McCord, who's sitting over here. There's many things to blame him for, Phoenix being one of them, but we can blame him for this too. He gave us the idea at a conference. He mentioned GraphQL, and I was like, I think I've heard about that, but I haven't had the time to look at it. And then I looked at it, and I said, I think this might solve all of our problems.
CargoSense is in the space where we have a lot of very specific client interfaces. We deal with logistics, and so you've got everything from an executive who wants to look at the 30,000-foot view of the sort of global supply chain, and you got people in a warehouse trying to move as fast as possible. And so we were on like our 6th user serializer REST API namespace, and it was total madness. And when we saw that the potential of GraphQL, we thought it was worth the investment, and it really has panned out.
Yeah, it's about the same time we were moving over from a legacy Rails API. It's funny to say that these days. A legacy Rails API over to Phoenix and OTP, and we had started to build Elixir microservices, and then we realized that that was stupid. And why don't we just shove these together and actually use supervisors? And wow, couldn't we make the API kind of unified and be able to look and walk around? And it was really cool. And then we thought, well, this couldn't be that hard to implement in Elixir. And then we started to read 60,000 lines of TypeScript, which is how Facebook launched it. And one really bad version came out that we pushed to production and actually used, which was cool because we were the only one using it, and we controlled both sides of it, so that's fine. And then other people started to use it. We had to make it flexible, and now we have a whole bunch of people, really, really, really smart people, sit in a room and answer questions that we don't have to answer, which is awesome, and give us PRs that we then merge and then use in our business. And we just try to steer the ship as best we can. And things are getting better every day.
So back to that query that we did a moment ago. So the thing to know about GraphQL is that this is the query language, and so each of these things that you're able to see here, orders, items, et cetera, corresponds to things inside, fields inside the graph. So here is a really simple part of this graph, and specifically it's 2 types inside of our graph. So we have an order type and an order item type. And you can see some of the fields that we were querying. On an order, we've got the customer number and the type for that. GraphQL is a strongly typed graph. This is incredibly nice for clients. When you push them a date time, for example, JSON's a really, really simple format, so the date time is going to come at them in a string format. And when we get back to GraphQL, I'll show you that. But the client can use this information to go, oh, it's a date time. I know how to turn date times into whatever a date time means in my language, whether it's JavaScript or Ruby or whatever, or Elixir. So this type information gets you a lot. You'll notice we've highlighted field items. So there's little code. The fields are where your Elixir code runs, and it's really entirely normal Elixir code. We've got this DSL for the schema, but there are functions that sit on these fields, and it's their job to get that value. In the case of items, we're using a little bit of a helper to use the knowledge we already have from Ecto about how to get data, and this will pull our list of items out lazily. So if no one asks for it, they don't get loaded. If someone asks for it, they get loaded.
If they ask for it a bunch of times, they don't get stuck with the n+1 problem.
Yeah, this handles n+1 under the covers in actually a really simple way, and in a way that's generic. We built this so that you could avoid that problem with any backend. There's nothing Ecto specific about this. And then, of course, our order item has the reflexive association. So you have an object, a node, the order, and you have another object, the order item node, and then links between them. It's the world's simplest graph. This graph gets exposed to the world through this query do macro. The query do macro gives us a special little object, and its job is to be the entry point. So at our query, the orders field you're seeing is the orders field right here, and its job is to pull the orders out of the database when there's our filter and walk from there. If conceptually, you can think of it as dots. There's like these little dots, and these are the objects, and the links represent the work between them.
And then the user queries that you saw back there are just trees. So you've got a graph, and you need to get data out of it. You obviously can't give it a whole graph of data that's got cycles in it. So you provide a tree as your query, and you get a tree back. So it starts at the special root type, which in the case of this for a query is that query root type that you saw exposed with query do. And then it uses those resolvers to resolve each field and walk along, resolves the values for each of them, and traverses to those fields, and so on and so on. Then at the end, it builds a tree of results, which is returned. And it's worth mentioning, too, that this tree of results can include errors, and so it's not an all or none. If one of those fields doesn't work for one reason, maybe that's authorization, maybe that's a failure, because there's nothing saying that this has to talk to a database. You could have one of these fields that actually talks to a third-party API, could talk to a REST API. This could be a service aggregator that sits on top of a bunch of microservices. Maybe they're not available. You can get back a partial set of results, and you can, using that partial set of results, you can interpret those results and use those in the UI however you'd like.
So the main focus for today, though, is this notion of taking GraphQL live. So we have this interconnected graph, and you know, when we started using this, we were using it to replace pretty traditional REST API use cases. You have a client, it wants to get some data, so it sends a request with a query, and then it gets some data back. But the first situation where we wanted something a little different was when we were trying to make, this is like a couple years ago, we were trying to make a change to the cargo sense uploaded files page. So we had this, we'd already been using GraphQL, so we had this query, nice and simple, and its job was to get all the uploaded files for an organization, a little bit of metadata, and then this report and export associations. So files for us are full of data, and we do a lot of asynchronous processing on that data. And we wanted the UI to kind of like light up the little icons and links and stuff as that stuff finished. So when we started with this, we got hooked up with a channel in no time flat. Thank you, Phoenix. And the job, we were just going to broadcast to the channel for the organization an uploaded file event. And then we had to build our JSON payload. And as I was doing this, and I was like using the ecto associations and so on, I felt kind of silly because we'd already just defined this super cool graph that we were using to pull our data out. And that's when it hit me. I could just have a string with the query and run it, and that would get me the data I wanted. Because it's a query language first, and not something built around HTTP or some particular transport, we could take that logic and run that query language on the server to get exactly what we wanted and reuse all of that logic. And that was kind of our first clue that the approach that GraphQL takes might give us a way past some of the challenges that I think we're facing when we want to do real-time APIs today. So, and as we started doing this, we realized that at least for me, a lot of what I had been using Elixir for was not making the most of what the language's possibilities are. You know, it's no coincidence that so many of the intro Erlang and Elixir examples are like a chat server or a TCP server or something. It has this notion of connectedness at its core. But we were, I don't know, for a long time, just doing basic REST in it. And REST is an excellent tool that's given us, we've all gotten a lot of mileage out of, but it's built from a platform that has a different set of basic concerns and focuses. Specifically, it's built around HTTP. You've got your URIs, you have this language of resources, you've got your HTTP verbs. But you know, if we had a REST API that we were doing the uploaded file stuff in, and we wanted to do the channel stuff, we'd have like had our broadcast function, we'd be building our JSON API or our JSON payload. What are we going to do? Call a controller with the non-existent con that wasn't there? Or like what? All these tools get lost in translation when we move from the sort of premise of REST, which is HTTP, into even HTTP2 and having the connections or WebSockets. Even deeper than that, there's, you know, there's, I think, probably a lot of people who might be hearing this and going, well, I don't know, what do I really have in my API that I'd want to expose in a live way? And you might be right, But for me, at least, as I started using other tools, I realized how much I had been limiting myself because I wasn't using language that made it easy to talk about real-time stuff. And when I was chatting about this for Bruce, he reminded me of a sort of amusing example of this, where as a kid, I really liked to disassemble stuff and play with the internals. And this took a shocking turn when I was playing with a camera flash and a bunch of batteries. And those, if you haven't done that before, it's a great way to make your hands jump excitedly. And it prompted my grandpa to deliver one of my favorite quotes, which is, "Play stupid games, win stupid prizes." And I'm really not saying rest is stupid. That's not the point.
I also, let me just state, I made Ben actually, I designed the slide deck, and I put this on here, and I told him that if he didn't say it, I was going to say it for him. And I wasn't going to couch it in anything else. And he's much more polite.
He is a wise man. So the quote stuck with me because the focus is on how much what you bring to something affects what you're going to get out of it. And in the case of REST, we're bringing to it a bunch of assumptions about the transport. And that's useful. But it means that if you ask a bunch of REST questions, if you're thinking in terms of REST, of course your answers are in terms of REST. And shocker of all shocker, you're not going to find live data there. So as we started using GraphQL, and as we started playing with Phoenix channels, we found ourselves asking different questions, and that gave us some different answers. Phoenix channels are awesome, and I don't mean to say anything negative about them, but they are a foundation. They're not a way to build APIs. So you like hook it up and it's like, okay, how do I specify what I want over that? Am I gonna do it with a channel thing where like the IDs are, of course, there's like topics for each URI thing that I used to have, and then we have IDs. People have been doing this, but we're all just kind of in the wild west of building these real-time APIs. And this is an enormous bummer if, like us, you spent quite a bit of time building your beautiful API, only to find out that you basically get to just start over again.
Well, and also, you're super excited about channels to begin with. You see the benchmarks, and you're like, wow, I could do such cool things. Well, now I have to create an entire language. And my background's in linguistics, so that's super exciting for me. But also not really good. The utility on that is pretty low when you're trying to, like build something as a company. And there just happens to be a language that works with this.
And so consequently, I think Phoenix channels are super underutilized. And it's not because it's hard to set up the connection. It's just because if you're faced with the question of like, do I do an ad hoc practice around getting resources, or do I just have the front end pull every so often?
Right, and how do you handle the life cycle? How do you handle saying that you don't want it anymore? And is that built into the language?
And so I think it's just often not seen as worth it. So GraphQL has a bit of a different approach, and I think it's a unified approach. So we're going to spend some time looking at what this looks like in a live demo, because what could possibly go wrong? So, you should really ought to wait until it actually works. I appreciate your enthusiasm. So what we're going to do here is I'm going to turn on mirroring so I can see what on earth I'm doing. And then we're going to play around with some stuff. So the story that we're going to use here, we're not going to show our production app. We've got like a bit of a simplified thing. This is what we built with the tutorial.
Yeah, has anyone here ever built a ordering system, a POS system, anything like that? Hands? You see some hands? You're going to be really disappointed by this. Super disappointing. Totally not real world, but data does go back and forth, which is kind of exciting.
So the basic idea is that just like we had, you can have a root query object. There's also a root subscription object. And I should make this larger. Is this visible to everyone? Oh, dear Lord, that's enormous. We'll figure it out. Is that readable to everyone? I'm not getting any wild objections, so we're stuck with it. So on a subscription, we have an order placed field. And for that, we're going to do something really similar, like let's get our customer number. We play this, we're not getting back data yet. Nothing's happened. Instead, what we've told the server is, hey, when there's something that happens to trigger the subscription, this is the data that I would like back. So let's order something. I'm super duper hungry. I don't know about you, so I'm having a Reuben and a muffaletta. We will submit this, and we have data, which is really cool. And just like in the queries, we can ask for different amounts of data. So we'll order some things again. We are customer number 15. And oh, I didn't hit play. That'll do it. There we go. We had to actually submit that subscription. We hit play, and now we have the ID and the customer number. This is not something that like the event is hard-coded to push out this stuff. So I have like one tab here with this particular query. We'll have another tab here, and it's going to ask for go away documents. Thank you very much. We're going to ask for like a lot more stuff here. We're going to get the items. We're going to get the
menu item
price of that thing, and we're all going to judge the pricing of the sandwiches on this thing. So over here, we're getting the items and the price. Over here, we're just getting the customer number and ID. And as we order, let's order 3 things. Bruce and I are just eating all the sandwiches. Here we have just the customer number and ID, which is what this particular client wanted. And over here, we have all this other data. None of this data, by the way, that item stuff is not preloaded on the basis of when this event happens. It runs this document, and exactly the same logic that said, hey, the query wanted items, let's go get those in an efficient way, now is also doing this. So the code for this is really, really, really minimal. So what we have is, this is our schema that we were talking about earlier, and this is the orders field I was referring to. So in this, we're under the query. So under the orders field, the query worked because we had a field named orders, and we said it returned a list of order. And under our subscription, we have an order placed field. That's why I was able to do order placed here. And we also said it returned an order. There's a little bit of topic setup stuff here. There's some under the covers. This is using, it expects some kind of pub sub implementation. We ship in Absinthe Phoenix with a way to integrate that with Phoenix pub sub. It's not tied to that. So we'll get to the topics in a second. But the point is, all of that is literally just around like making sure the right data gets to the right people. The logic needed to handle different clients for different amounts of data return is literally just this one line, because we're pointing to the same node in the graph that our queries were pointing to, and we can immediately reuse all of this work. And this is what I meant by having a unified approach. Whether you are asking for stuff, like under orders, or whether you're creating something, changing something in the graph, that's what mutations do. Each of these things links to the order part of our graph, and consequently, we can do all this awesome stuff right underneath.
Worth mentioning, too, if you can show the app that you actually submitted the orders with.
Yes.
So generally speaking, you would expect when he hit submit for this probably to do something like a post. This is actually going over WebSockets as well. The actual mutation is going across WebSockets, just because I happen to have selected a WebSocket as part of the binding for the client-side framework. But it would work just as well if I was using HTTP. It doesn't matter whatsoever.
Right. Yeah. So we said we wanted the WebSocket in order to get this real-time connection. But then once that connection was set up, it's not like the queries or mutations depended on any of the HTTP stuff to begin with. So we just run that over that too. We don't pay into the penalty of setting up the connection again. And when HTTP 2 comes out, this will all, can the browser talk HTTP 2 to the server? Awesome. This will all just basically work again.
This is what I meant earlier when I said that GraphQL is a query language and not an API. At its core, it's completely decoupled from the transport that it's sitting on top of. So you can send it across basically anything. I've even built such stupid things as a replacement for LS that uses GraphQL. I don't recommend it. It's very long. But you can do whatever you want. You could have a system that sent out emails as part of subscription if you were crazy. So it's a very flexible type of system.
And what's cool about this is in the ordering example, you can imagine that there's 2 very different use cases that we want to handle. So the first is the kitchen itself. When someone places an order, you're going to want to know what things were ordered and how many of them so that you can go about making stuff. But you could also imagine an interface that was exposed to the customers themselves so that they know when their order is ready to be picked up. So what we've got here is, behind the scenes in this little application, we've got basically some pretend little gen servers that do work. There are our cooks, and they're going to actually complete these orders and the items on these orders.
It's the most complicated bit of stuff you've seen. Like, for a demo yesterday, he was writing this, and I was like, yeah, okay,
please don't copy the style of stuff that we did to do that. It's like spawn, fun, spawn, fun. It's great. Yeah. So, but the point being is that it's going to be making some changes behind the scenes. And without, again, they're running on exactly the same schema. We have a way to talk about orders that get placed and some orders that get updated. But this is all the work that went into supporting this, the totally different use cases. So on the kitchen UI, if we order some things and we submit, it would help if I loaded the UI correctly. And there we go. I told you, this is the risk of doing demos. It might be too small. No, or it's just not going to cooperate.
This is the part where I say, this stuff is written in JavaScript.
Yeah. Fascinating. We're going to restart our... Well, what we're going to do here is submit these things, and it's quite possible that there's some kind of caching issue. Don't look at the curtain over here. This is the... The basic idea is that we're still working out some of the kinks, especially with the client library. So GraphQL support on the back end is pretty new, and and as we'll talk about sort of where we are in the state of all this in a minute. But the kinks as far as sorting out some of the client connections is still in progress. So we can submit an order, and over here in the kitchen, we can see we're pulling enough data to get information about what we're trying to...
Well, to be clear, we're not polling data.
Sorry. When we set up a subscription, we can actually see this in the frames. Although, if I don't know if I have a way to make this large enough. Possibly not. So we can see when we hook this up, we ask for a subscription. And I don't think that I'm going to be able to make this large enough to see. Maybe if I copy this.
It's fine.
OK. Long story short, we run a subscription, and we ask for exactly what we need, and then it gets pushed to us to drive this UI. Over here in the announcer UI, we're only asking for the customer number, because when this gets done, this will show up, and it will tell us that, see, it's all done, so it showed up here, and then someone will come and pick it up. That's another little gen server, and it goes away. So each of the UIs could ask for exactly what we needed. And so we actually did set this up on elixir.ngrok.io, which is a URL that you can hit. And I will put this up here.
If you thought it broke before.
If you thought it broke before. You can go to this UI, and you ought to be able to submit stuff and play around with this yourself. I'm going to run this little subscription here and see if we can get the data of people hitting this stuff. So if I run it over here, and I will order something, and I will submit it, and then we get that thing, and we'll see if this changes, if any of you are adventurous enough to try to place something.
This is just an internet test.
I have we've got quite the list of things to blame in the event that this doesn't go well.
URL
starting
again?
with yes, yeah. Let me put that right down there, and we'll make this a little taller, or shorter rather. You can do it. There we go. Is anyone able to connect to that? No. I definitely tried. Elixir.ngrok.io. No luck? You got it? Someone's got a thumbs up.
Oh, I see.
Well, the internet gods have not cooperated with us. But the basic idea here is that you could have we actually have a whole bunch of stuff in here that unfortunately then the relevance of which is less for the moment, but to try to make this as performant as possible. So Elixir has provided a really excellent platform to drive this kind of stuff. So every other implementation out there, as far as I know, if several hundred of you had successfully gotten to the URL and gone to this web page, it would have, each of you are going to submit this GraphQL document. And So that's several hundred documents that are going to sit on the server. And when an event happens in Node.js or in Ruby, it goes through every one of those things and has to run it. Well, if you're all asking for a bunch of data out of the database, it's all exactly the same data. There's for a given order. If you're all looking at the kitchen page, for a given order, it's going to be the same items. So Elixir makes it incredibly easy using the Elixir 1.4 registry to aggregate information from different processes, make sure it's safe to do so when those processes go away, the documents go away. But then we can use this store to aggregate work. And so we will run the document exactly once and then use all the awesome optimizations that Phoenix channels have to push out the value to everyone. We have a branch with some features that will handle, like you might wonder if you're authenticated. If different people are authenticated, we can't just assume that a given text blob or a given query will be valid for everyone, because there was going to be different rules for each people. But the same kind of batching feature that made sure we weren't doing n+1 earlier can even handle n+1 across a set of documents. And so we will do a single database lookup for all the items, no matter how many subscriptions we've got and how many different rules we have to handle. And all of this is enabled in a way by the Elixir language itself, and how easy it is to talk about work concurrently and have the different processes message each other and so on. This would be so much more difficult. And there'd be a lot more risk, because if some client hanged or the process trying to do one of these things was taking a long time, it could slow down all the other events that were happening for other people. And we don't have to worry about that at all in Elixir. So this feature itself, which I will unmirror and go back to our slides, the feature itself is pretty new, and in fact, we just pushed the 1.4.0 RC0, and it's definitely 100% bug-free at this point.
So the footnote on this, I had a footnote, but it was too long, and I couldn't fit it on here. There's probably bugs. There's probably lots of them. We've actually had quite a few people using this in beta, and we've had some really good feedback. And I'm going to move on to the next one.
Yeah.
So this is something that's worth noting. Before we go to stable, we're going to have a lot more client libraries in and around JavaScript. We have a basic JavaScript package that's called Absinthe Phoenix.js, which basically handles the wrapping of channels and being able to push data back and forth. However, that handles vanilla JavaScript, but there's a bunch of features in and around Apollo Client and Relay and their semantics with their network interfaces. There's a team that we're working with actually that we're building an additional set of bridge packages for those. Those are coming along very nicely. And we do also have people, for those of you here that are interested in Elm, we've had several people use both Absinthe itself and also these new subscription features with Elm and really enjoy it. So.
And it's, we were looking at a lot of, it's really easy to see how this really makes quite the difference for the client experience, because the client can now ask for this real-time data, and they can get it pushed to them. It makes a big difference on the back end, certainly as far as the ease of use and usability for making that an integrated and unified part of your API. But as we were doing this, we realized it's actually part of a bigger question, I think, that's happening around the ways in which we can use the Elixir language itself. Because we weren't doing a lot in our application to make it to have meaningful events. Like, if you don't model the language of your application to talk about things occurring, you don't have a lot to say to people who want to know what's happening. And so I think that the most interesting part of this for me, or certainly one of the really interesting parts, is going to be how, as this becomes easy, we can let this new tool drive new ways of thinking and new approaches in our applications itself. If you thought this was cool, we have a book that can take you through this a little more step by step. It came out in beta last Tuesday. Many thanks to my co-author, Bruce, for making this.
Last Tuesday, I think you meant it just came out a couple days ago. So,
that was Tuesday, right?
Huh?
Oh, no, it was Wednesday.
And it wasn't last Tuesday.
Oh.
This is the kind of these are the type of substantive discussions we have about building APIs. And
we all know time is a stupid hard API, so
Yeah. So, anyways, yeah, it just came out, and it was a lot of hard work, but fun. And it's my second book. In his first book, it's 170+ pages right now. We have 3 more chapters left. The chapter on subscriptions is done and is in the book. It is subject to change, of course, because it's in beta. And we have more stuff that will be coming out, some possibly interesting things in and around Phoenix Views and Absinthe as well. So whether or not we can sneak that chapter in, we're looking at it. And we've done, Absinthe has benefited greatly from us writing this book. We call it book-driven development. It's worked out well. We knew we needed to write a chapter on subscriptions, which means that we needed to build a feature called subscriptions that it could be written about. And that worked.
We've been told that this discount code is good through today, but I don't think past that. So if you are interested and you felt like we went through a little quickly because we did, then that's a good way to dive into it more deeply.
If it makes you feel better, there was a 6-hour tutorial that we taught the other day, and they probably thought the same thing. Pretty sure we could teach this for several days. It's a very deep topic, GraphQLs in general. But once you really dive in, it is really transformative in the way that you think of building APIs. So I think we have maybe
time
some
for questions.
Yeah, 4 minutes. If you've got questions, I think that,
I can just pontificate about the internals if otherwise. Yeah.
How do you handle multiple nodes for subscriptions?
That is a great question, and the answer is that, once again, we get to blame Chris McCord for being great. So the Absinthe core project has a behavior around PubSub and just a couple of callbacks it expects. The Absinthe Phoenix project gives you a way to use Phoenix PubSub as your PubSub, and then we just get to piggyback on all that cool stuff. So it does distributed Erlang, it does Redis, it does any adapter for that will work here.
So if you have multiple, sorry, I'm gonna repeat here. So if you have multiple clients with different updates, how do they associate those updates?
Whether or not you have a cluster is transparent to the client. The client says, I have a document, I want updates on that stuff. It doesn't care whether you have nodes or not. And we make sure that all the events get moved around so that everything runs. I'm going to do one from this side of the room if there is one. Going, gone. Oh, Chris McCord. Oh yeah, we didn't talk about that, did I?
The trigger
oh, yeah.
feature?
Chris McCord was pointing out that I didn't tell you how you actually might push an event in GraphQL. So there's 2 ways to do it. There's a very simple way, and this runs the risk of running into my simulator. So most of this code here is, I'm just going to copy this out. Swink.
Avert your eyes.
Avert your eyes. So if this was, preferences.
See, they didn't see it. They're safe.
So this is, if you have an order struct, this is, you can think of this as basically, or something like that, right? You have an order. This is how you do it kind of out of band. You have your PubSub implementation. Like I said, we're using Phoenix, so we're building off of our endpoint. You have the thingy that's going to be the root of the event that you're publishing out. And then these are the GraphQL fields and then the topics that you're publishing to. This is another area where we differ a little bit from some of the other implementations in that they all have something that's a little bit like this. But especially if you are making these changes through your graph anyway, which is to say you're using mutations, like placing an order here, the schema is already the place where you should be putting sort of the data characteristics of your API. And so we have this notion of a trigger. And you can specify a trigger on a subscription field. And this is the name of a mutation and then a way to build the topic. And this is what we like about this is the config here is when the subscription is given to you, you can build sort of the topic that you're filtering for. So if we had, you only want orders at a particular place, you could have an argument here that was the location ID. This would show up here. And then your topic might be just like the ID. And then when you push something out, you'd be pushing it out to the order's location ID. And this is how there's a correspondence between the events and how they route to the individual documents that they care about. And we like that you could have this all in one place. You can push to many things. So if you also wanted a catch-all thingy. There's nothing special about Splat. It's literally just a convention we were using. There's a lot of stuff here, and I want to let other questions happen, but that's like the 10-second version. There was someone way back here that I skipped over. Green shirt, yes.
I was just wondering, like, what sort of stacks are you using this with in production? Is it all Phoenix, like Postgres?
Yeah, we're using this with Phoenix and Postgres. Oh, I'm sorry.
What stacks are we using this with? Is it all Postgres or something else?
Yeah, we're using this with Phoenix and Postgres. There's a lot of conversations ongoing right now about how do you catch up if you've missed events, which incidentally is almost identical to the same question that Phoenix Channels has been asking and the same question that GenStage has been asking. So we're mostly just hoping they'll do that hard work and we get to piggyback on it. So, but no, that's what we're using. Oh, are we out of time?
Yep.
All right.
Yep.
Well, thank you so much. We'll be up here if we have any more questions.
We have stickers too.
We have stickers.
So.